Hi there, my name is Walker Reynolds. I'm the president and managing partner of Intellic Integration. We're a full-service systems integrator based in Dallas, Texas. We have offices in San Antonio and Ithaca, New York. And we're also an ignition by inductive automation subject matter expert. The purpose of this video is we built a MQTT demo. I'm not going to be real formal here. We're just going to kind of go through it, get into the nuts and bolts, and kind of explain what MQTT is, how does it work, and for the developers that are watching this video, kind of show you how you can get started using MQTT with Ignition. For the end users who are considering MQTT or have bandwidth issues or want a new way of doing things, this is maybe a thought of experiment or some food for thought for those folks. There will be a full explanation step by step on our blog. You can get to the blog by going to blog.intellicintegration.com or just going to our website and clicking on the blog link. With that, we'll go ahead and get started. So the demo here basically was a 5-step process, and I'm going to take you through that on our Fabricator. But we're going to start by kind of going over what is MQTT. So MQTT is a communications protocol. It is the communications protocol that Facebook Messenger is built on. I mean, it's a robust, very, very lightweight protocol that essentially sits on top of our communication stack and doesn't really care what's underneath it. Doesn't care what the format of the messages are that it's going to be sending back and forth. Super lightweight. It reports by exception. So if you think of all of the tags or all of the messages, or as MQTT likes to call them, all of the topics that exist within the MQTT space, it only reports back. The edge devices or the publishers only report back to the broker the values that have changed, the deltas. So it's reporting by exception. MQTT is really the centerpiece of what we refer to as IIoT, the Industrial Internet of Things. Right? Internet of Things is all big hullabaloo, and everyone is all excited about it, and we read about it all the time. But not many of us have seen a lot of real-world applications in industry. And the reason why is because in my talks with developers, end users, and even the software and hardware developers that are building MQTT compliant software and hardware, I think there's a disconnect between the excitement that MQTT bears in people, and there's a disconnect between that and the application in the field. How can I use MQTT to make my business more efficient, and how can I do more with less, which is ultimately the core of innovation, right? So MQTT is a protocol, and in this demo we're going to basically compare it to OPC UA. MQTT is a sister of OPC UA, although they handle messaging completely differently. So why MQTT? The first piece is MQTT is super lightweight. That means the packets are super, super small. The second piece of it is that MQTT reports by exception rather than having a server polling all of your edge devices and getting all the tags at some set rate. So we get to eliminate a lot of the overhead and a lot of the consumption of bandwidth on tags that never changed, on values that never changed in the field. Okay, so what we're looking at the top here is this is a traditional polling model. Here in the center, this would be something like Topserver, Kepserver, or Matricon OPC, or any other of a million OPC UA servers. Down here on the bottom, you got all your PLCs and all your instruments and devices in the field. And how does the OPC server, what is the OPC server PLC relationship, and what is the OPC server client relationship like, right? So you got your OPC server here in the center. I do some configuration in my server. I establish a connection with my PLC. I tell it how often I want it to go get my tag updates. Do I want to respect the client scan rate? Do I want to scan at my own rate based on the server? And then I call out, hey, PLC, send me all your tags. And the PLC says, oh, here you go. Here are all my tags. And then I go to the next PLC and send me all your tags. Send me all your tags. And the speed at which we can communicate to the various PLCs I have in the field is going to be a function of how many threads are available on the server that are running. What communications protocol am I using here? Is it serial? Is it Ethernet? Is it Modbus TCP? What is it, right? So that's going to play a lot of factors in terms of how quickly we get around to all our PLCs. There's a lot of limitations here, obviously, right? So, I mean, first off, it's incredibly inefficient to do a round-robin polling to all the PLCs we have in the field. Also, I got to do configuration everywhere. So if I want to get tags up here in my clients, so whether this is Wonderware or Ignition or FactoryTalk, doesn't matter what we're using up here, right? I've got to do some configuration here for my tags, unless my tags are browsable and I can drag and drop them from my OPC server, browse my server and drop them in. But I've got to configure my tags up here. Hey, these are the tags I want. Make sure I get all my address string correct. Here I got to configure my tags inside my server or do an explicit OPC read through the server. And then I've obviously got to write a PLC program out here in the field, right? So the way that the server calls out to the PLCs is very much the same way that the client calls to the server, in a round robin fashion. The server can only respond so quickly, right? So that's traditional polling, where the server sitting in the middle is the most important thing. MQTT uses a pub-sub architecture, which is completely different. Essentially what's happening is all of the data is being pushed to the broker. The only thing that the broker does is it sends the updated values of the topics, and think of a topic as a tag. All the broker does is it keeps a list of all the people, of all the topics that are being published, all the tags that are being published to it, and all the people who are subscribing to those topics. Okay, so up here, what I've got is I have a device that's just a subscriber. So in this case, let's think that this is a web application that is connected to the broker, and he has told the broker, I'm subscribing to 3 tags: temperature, humidity, and sunlight. And the broker just keeps track of those 3 topics. Maybe they come from instruments out here. And then when they change, the broker just pushes those. They get pushed from the instrument to the broker, and the broker pushes up to the subscriber. Only the values that changed. Okay. This is a stateful connection. So any of the devices out here that are connected to the broker, the MQTT is set up so that it's a stateful connection. We know that the instrument is connected to the broker. In this case, we have a pub sub, so this could be something like Ignition, where Ignition is able to publish values to a topic. So let's say I have a topic that is hello world, okay, and the value of my hello world is test. So if I'm looking in my tag browser inside of Ignition, and I navigate to the tag world in the directory hello, and it says test, then I change it, and I change the value to, say, word. Well, what it does is Ignition will publish that update to the broker, and then the broker will push that updated value to anyone else who is subscribing to Hello World. So in our case, the architecture that we're using for our demo, I have my broker here in the middle, which is a Raspberry Pi 3. I've got Ignition running on a server, which is out here. And in this case, I'm not using Ignition as the broker, although that's very common. I'm using it as just an agent. I have a Arduino that is connected to a temperature instrument, a temperature sensor. I have NQTTeespy running on another server, which is just a utility that gives us the ability to talk MQTT and subscribe to topics and update the tags and all that kind of stuff. And then I have a Kepserver IOT Gateway that's running on another server, and I'm going to show you how you can use Kepserver and MQTT to send tags via MQTT, in this case to Ignition. So the advantage here is that the only thing that's getting sent are the header itself, or the packets that get sent over the network are already inherently smaller with MQTT than they are with other protocols. Much, much smaller. And the fundamental difference is that we only the agents, the edge devices, are only sending the updated values. They're only publishing the values that change. So let's say that this is an RTU I've got in the field. Let's say this is a Wago PLC, because Wago now has MQTT compliant PLCs. Our team at Intellic worked with Wago to use Sparkplug to get their PLCs up and running with MQTT. But let's say I've got 100 tags, okay, and out in my RTU, and 3 of them just changed. So essentially what happens is our agent says, hey, Mr. Broker, I've got hello world, I have hello all, and I have hello mom. Those 3 values just changed, and I'm going to send the updated values, new value, all the way up. All 3 of those get published, only 3 of 100, with a packet size that's much, much tinier than than most packets that you see in industrial communications. And then the broker does the same thing, only sends those 3 updated topics out to the subscriber. All right, so I'm gonna go over my architecture a little better. Okay, so what I've got is I've got a Raspberry Pi 3, and I've got an Arduino ESP8266 with an LM35 temperature sensor at the center of my demo here. So what I've got on the desk over here, you'll have to trust me, is I've got my Raspberry Pi, I have my Arduino, and I have my temperature sensor, and the temperature sensor is wired into the analog in on the Arduino. The Arduino, I wrote some C code where it connects to the Wi-Fi network, and then through the Wi-Fi network, it is publishing the updated values. It's publishing 2 topics. The first one is a tag called out topic, and then the second one is a tag called Intellic /pyramid /temperature, or temp. And it's publishing those topics to this broker, okay, which is a Raspberry Pi. The Raspberry Pi is publishing all of the topics. It's subscribing to some of the topics that we're publishing, but it's also publishing the topics out to all of the other agents that are connected to it that are subscribing to those topics. So we have Ignition, we have NQTTeespy, and we have Kepserver, the Kepserver IOT Gateway. Now the Kepserver, I only have publishing data to the Raspberry Pi. That's all it's doing. It's just gonna, and I'm gonna show you how that all works here in a second. Down here below is I'm gonna show how this translates into an industrial implementation in a moment. Okay, so how did we our project? There were basically 5 steps to build my demo. Okay, and the demo that's running inside of Ignition is basically this window that is monitoring this temperature sensor, my out topic, which is hello world, and then it's incrementing. And then I've got my Kepserver IoT Gateway tags. Down here is the MQTTeespy, so these are the topics that are being published by the MQTTeespy. And a topic, think of a topic as a tag. So over here inside of my MQTT engine, this is the MQTT module written by Cirrus. I've got my IoT Gateway JSON that's coming from Kepware. I've got my out topic tag. I've got my Intellic pyramid temperature tag, and I have my hello world tags. Okay, so this in a nutshell is the demo, and I'm going to show you how it's all built and how it works and kind of the neatness of it. In addition to that, I've got Ignition is also talking to Kepserver via OPC UA. So if I come down here and I turn on my Kepserver gateway, so if I start the runtime service, now I'm also viewing Kepserver over OPC UA. Okay, So in these tags, it's OPC UA, and down here, the same values of those tags are coming over via MQTT. Okay, and right now I've got a little timer running, and every 3 seconds it updates. I'm essentially parsing the JSON and then writing those values into a data set, and then putting that data set into this table. But for now, I'm going to go ahead and turn the Kepserver runtime service off because I keep getting a notification. Okay. All right. So it was basically 5 steps. Got to install Mosquito on a Raspberry Pi and NQTTeespy on Windows. So I've got my Raspberry Pi right here. So what I've got running on the Raspberry Pi is Mosquito, and it's the only thing that's running on here. I'm going to explain what all these windows are here in a second. To install Mosquito, I went to switchdoc.com, and all of this will be in. This was the best tutorial I found to install Mosquito on a Raspberry Pi. It was a piece of cake. Once Mosquito's up and running, there are basically 2 commands you need to learn: Mosquito sub and Mosquito pub. Very, very simple to publish to a topic and to also subscribe to a topic. And I'm going to show you how that works in a second. So I installed Mosquito. I just got to stop the server. I do a quick update to the mosquito.conf. I had to restart the server. I subscribe to a topic in a new terminal. I'm going to show you that in a minute, and publish a topic in a new terminal. So what we're viewing here is right here. This window right here is where I'm doing all my publishing. These 3 terminals are monitoring subscriptions. Okay, so in this case, this terminal right here is monitoring the temperature probe, or the temperature sensor, the LM35. So every time it's updating, the Arduino is publishing to the broker, which is the Pi, and then this terminal is has subscribed to that topic. And so every time the value changes, you'll see it change in this. Window. And what I'm going to do is I'm going to go ahead and breathe on this temperature sensor, and you'll watch the temperature increase. Ready? All right, so the temperature went up to 250 degrees, or 200. It's actually 25 degrees centigrade. In addition to the MQTTeespy, I want to watch MQTTeespy. I don't see it. I'm looking for. Where is that jar? Might be in the downloads. Sorry. It is not. Okay. Okay, so I'm gonna create a new connection. It'll be Pi, and it's 192.168.0.33. I'm going to open that connection. Yes. Okay. What I'm going to do here is I'm going to put in a hashtag. What that means is I want to subscribe to all of the topics that are being published. That are all of the topics that are being published to the broker. Okay. So right now I'm looking at the temperature topic, but also I have this out topic that is being published by the Arduino. So one of the other things I can do here, I'm going to go into my into VNC here, is I'm going to go ahead and I'm going to publish an update to a couple of other topics. So I'm going to publish Yankees. I'm going to publish update to world, and I'm going to publish hello all. Intellic, and hello mom is another one. And one of the things you'll notice is that you will not see a new value when you establish a subscription. You won't see a new value until the value changes. There isn't a stateful. The broker doesn't send you the old value. It sends you the next change. Hello mom, and we'll just put Walker in there. Okay. So now if I go back, now I'm subscribing to all. I'm receiving the updates from all those tags. Okay. I've also got Ignition running, and Ignition is also subscribing to those tags. So you'll see that we received all of these other updates. Oh, the Chicago one is the other one I need to send the update to. So let me go back here. All right, so this is the MQTTeespy, which is acting as an agent. I've got Ignition, which is also acting as an agent. I have the Raspberry Pi, which is acting as a broker, and I have the Arduino, which is acting as an agent. Now, the broker can also, so from within the Raspberry Pi, I can create new topics, or I can create new topics in MQTTeespy. So if you look at our Ignition demo here, so if you look at our demo here, I've got my temperature sensor value, and if I heat this up, we'll watch that value go up. I've got my out topic, which is hello world 1059, which is coming from the Arduino. I'm going to show you that code in a second. And then I also have all of the topics that I'm bringing from MQTTeespy. So right now I've got all of Chicago, Mom, New York, Texas, World. So what I'm going to do is I'm going to add a new topic, and that topic is going to be hello. Let's do Colorado, and we'll put Denver in there. So what I'm doing is I'm creating a new topic inside of hello. So once I fire it, you'll notice instantaneously Ignition is, since in Ignition we're subscribing to all the topics as well. I've got Denver, Colorado, and if I come here and I run my window and I update here, what I've done is I've dynamically updated that object in my window. So think of that topic, think of that tag as an instrument. The beauty of MQTT is that MQTT gives us the ability to create self-aware SCADA systems. So as I plug new agents into the network, so as I have a total flow that now talks MQTT, or I have a Wago PLC where I've written a new program, and inside my program I've defined all my topics, which are my tags, and I've configured it to publish to my broker. As soon as I plug that PLC in, it's going to start publishing the tags to the broker, and if I'm subscribing to that broker, those tags are going to show up automatically. Okay, so let me explain a little, kind of a little deeper what I mean here. All right, so what does a publish look like? And actually, it'll be easier to show this in the Pi. So if I want to publish to a new topic, so I'm going to create a new topic in the hello directory from here as well. So this is the Raspberry Pi is also acting as an agent, even though it's my broker. So I can go Mosquito pub. I want to publish debug. I want to publish a new topic. It's going to be hello, and it's going to be Florida. and the message that I want to publish to that topic is Marlins. Okay. Oops. Need to learn to type. All right. So I just published a new topic, and so now obviously it's going to show up in my agents. Hello, Florida Marlins, and in my ignition application, hello, Florida Marlins. And if I update here, now we've got the Florida Marlins inside of my template repeater. The point is that the Florida Marlins could be a device that I plugged in, and underneath it, it doesn't have to be just a single tag. It could be hundreds of tags, and I could create a SCADA system that is stateful. That is, I know that I'm talking to all my devices in the field. It uses a fraction of the bandwidth that all other protocols use because we're reporting by exception and we're using much, much smaller packet sizes. And it is self-aware. It's dynamic. And I mean, fundamentally, that's a game changer. So what are the downfalls, right? The shortcomings are not everything talks MQTT. There's tons and tons of legacy hardware out there that doesn't talk MQTT. So right now what we have to do is we have to create gateways. And fortunately, companies like Alexis, so these are the guys that we use primarily. Oh, hold on. I think it's Alexis Corp. So Alexis produces gateways that, so we want, the ReadyGate 400 is what I use. So the ReadyGate 400 is what we use here. So what these gateways do is these gateways will convert existing protocols into MQTT. And there's basically an XML configuration file that sits on top of there. So think of that XML configuration file as similar to my code that I've got running in my Raspberry Pi, or the code I've got running inside my Arduino, which we'll go through in a second. The ReadyGate has a configuration file in there that will consume what we've got in the field coming from our PLCs, RTUs, and instruments, and then convert it into MQTT, and then the ReadyGate becomes our edge device, not the PLC. But companies like Wago and Red Lion and a bunch of other folks who are in the process, Moxa and all that jazz, they are producing hardware that is MQTT compliant right out of the box. So that means your PLC, not only is it going to talk OPC UA or CIP or whatever other protocol it's going to talk, but it's also going to talk MQTT. And that is a game changer. I mean, that's a big deal. So you'll notice in my notes down below here, that's what this looks like. Okay, so right now our demo is here, right? It's just these 5 agents all together, but using Wago with MQTT, Alexis ReadyGate with PLCs, RTUs, and instruments on the other side of it, Ignition Edge, which is a new release by Inductive Automation, which is it's a stripped down version of Ignition where you can purchase the MQTT modules so that you can have an Ignition HMI out on the edge. Ignition can be talking to your instruments via various protocols, and then it can act as the edge device and publish your tags back up to your central Ignition broker. These are the 3 implementations, just 3 of lots of different styles of implementations that we could implement to get systems onto MQTT. All right, back to our demo. All right, so we install Mosquito on a Raspberry Pi, then we set up our Arduino. This is pretty simple. I showed you the picture of, I basically just have a single sensor going into that Arduino, and then I wrote some code. It's a combination of some code I found in some existing projects and then some custom C code that I wrote. But that code is here. I'll put this in the blog post as well. First thing we do is we connect to the Wi-Fi. Then we create an ESP client, a pub sub client. We start all of our MQTT stuff down here. The first thing we do is we're going to print to the serial. We are going to publish out topic which is we created a topic called out topic, and we're publishing hello world to it. And then I created this topic called Intellic pyramid temp, and I write a 0 into it. Okay. And then down here in the loop, all we're doing is reading the sensor right here, converting that to a string, and then publishing the value of the sensor to this topic in the loop. That's all we're doing. It only updates when the value changes. So if I wanted to, I could add another topic in here and run it over and over and over again. Okay. The next step is I install and set up the Cirrus Link MQTT modules in Ignition. So first thing I would do is I went here and downloaded Ignition 791 and installed it. And then I downloaded the Cirrus Link modules. I did download all 4 of them, but I'm really only using the engine for this demo. Cirrus Link's got great documentation on their website. And I used the MQTT module installation and configuration pieces to get this done. I downloaded MQTTeespy, which is an open source Java application that just gave me the ability to create another agent where I could publish and subscribe and do any debug. It turned out there wasn't any debug. I got that here. This was an explanation on how to use it. Then the last piece I did was I went to Kepware to install the Kepserver IOT Gateway. So the IOT Gateway is an add-on. I think this came out last year. I think right before the conference. Anyway, this essentially what this does is this allows Kepserver to publish tags via MQTT to a broker. That's what it does. Now, in my case, I'm consuming those tags in a JSON, and I'm going to kind of show you how that all works. Kepserver is not publishing them as tags into Ignition. They're publishing them as a single tag, and then all the tags are in one JSON, and then I'm parsing them. There's a couple. You've got some choices when you're configuring. The manual is here, and then this is our Ignition Gateway. So when I installed the MQTT module from Lexis, I just went into the MQTT engine. I set up my Raspberry Pi as a broker, and then inside my Pi, I went to namespaces, and I created a custom namespace, and all it is a hashtag. And what that means is I want to subscribe to all the tags that are on the broker. I could put in a filter in here where I could say I only want to subscribe to everything that's in the hello directory, or I only want to subscribe to everything that's in the Intellic directory. But in this case, I put hashtag so that I could subscribe to every topic so anytime the broker receives an update, I'm getting that in my, I have a subscription to it. And that's literally it. That was all I had to do to set up Ignition. And then as soon as I did that, any topic that's published to the gateway is I'm going to receive an update on it. Okay. Yes, I'm going to receive an update on it. Go back here. On the Kepware, I got sidetracked there. All right, so I'm gonna start a runtime service. I leave it off primarily because I don't have my systems integrator license on this, so it gives those little annoying pop-outs. Right, so I'm going to go to my configuration. It's very, very simple to set up the IoT Gateway. You're going to create a new agent, okay, and then in that agent you're going to identify some properties. So all I did was put in the IP address and the port to my Raspberry Pi, which is my broker, and then under my message, I decided to select the advanced template. So all this is saying is what is the format that the message is going to be sent to me. One of the beautiful things about MQTT is that MQTT does not care what your message is. It literally does not care. I can send a blob file for SQL through it. I can send a SQL query through it. I can send a JSON that's got hundreds of tags inside of them. I can send image files if I want to, binaries. I could send binaries over the as a payload. It doesn't matter what the payload is. It literally is just, if there's no authentication, like right now I have anonymous authentication set up, so I don't have to put in a username and password every time I try to publish, because this is a demo. But if there's no authentication whatsoever, then all you have to do is put in the IP address and the port, and then the topic name, and publish to it. Boom. That's simple. So once I did this, once I set up the IoT Gateway, this IoT Gateway is publishing to the Raspberry Pi, and there's no direct connection between Kepserver and Ignition. Ignition receives that IoT Gateway from the broker itself, because I'm subscribing to everything. Okay. Then what I'm doing, and I'll kind of show you what I'm doing here. So then what I do is there is the IoT Gateway returns Control-C. Very annoying. Cancel. So this is what the JSON looks like. So the JSON that Kepserver is sending back to me is the timestamp, and then values. ID is your tag name. Value is your value. This is quality, and then this is the timestamp in I think Unix time or cron time. I'm a coder, but not that much of a coder. And that's it. And then Ignition is receiving those tags. What I'm doing here is I am then saying, go read these tags. Go read the name of this tag, and then I'm parsing the dictionary. I'm building a new data set, and then I'm updating the tags in this table. So what you see here is channel 1, device 1, tag 1, and then the values. I have it updating every 3 seconds or so. The thing that excites me the most about this whole process is this whole idea of a self-aware SCADA system. That's the piece that really gets me excited, because at Intellic we do the most difficult projects. Oftentimes we're coming in behind other integrators that couldn't quite figure it out, and we're taking on these massive projects with hundreds and thousands of PLCs, and scores of different integrators worked on the development, scores of different integrators and OEMs worked on the development, and we have to figure out a way to normalize unnormalized tags. And what MQTT will give us the ability to do is essentially create our objects out at the edge on brownfield implementations. But more importantly, I can take, with the other Ignition modules, the other MQTT modules here, I could actually read tags from OPC and then use MQTT to turn them into common objects that I can then consume in my SCADA, MES, and OEE implementation. Okay, I'm going to go ahead and shut off Kepserver because it's driving me crazy. All right. Yes, I want to stop. So I'm going to add a couple of more topics in here. Hello. Let's use hello DC, and the value will be Congress, and we'll do one more, hello Ohio, and it'll be Browns. All right, back to Ignition. Let's go ahead and update these. Boom. And that is the extent of the demo. Let me make sure that I covered everything I want to cover. Kind of close out what I mean here. Okay. Yeah, so we did Kepserver, and then I configured the Ignition window in the template. And that's the extent of the demo. Again, I'm gonna I'll do a complete blog post that takes you kind of step by step how to pull this off. This at a minimum, this will get you started playing with MQTT, and I would love to hear from other folks, how they might implement this. Again, our architecture was designed. The architecture I did here was really designed to kind of show off how quickly, how quickly MQTT responds, but also how really we'll be able to plug instruments in, plug hardware in, and have it be immediately available. The tags will be immediately available for consumption by other applications. And this isn't going to be just SCADA and MES and OEE. This is going to be ERP systems and accounting software, and the days of having in oil and gas applications, right? Having room full of people who are doing nothing but just managing polling rates so that they can rob Peter to pay Paul. I need to rob some bandwidth from over here so that I can update this. I can pull this casing pressure every five minutes as opposed to every 5 hours. I mean, those days will be long gone. We'll be able to appropriate those people into places that are into positions that are can help innovate and improve a company's operations. So that being said, I'm going to make there'll be another demo where I'm going to show you how to use the ReadyGate and how to configure the ReadyGate and in that implementation I'm going to use Ignition as the broker instead of the Raspberry Pi. In this case, I used the Pi because I wanted to use something that had very little horsepower but showed how functional it was. But that video will be coming in a couple of weeks. Again, I'm Walker Reynolds with Intellic Integration. If you got any questions, please don't be afraid to holler. My email address is on the blog page and my cell number, and you can find us on Twitter and Facebook and LinkedIn and all those other places. All right, thanks for watching.